Welcome to Science to Sleep By. Tonight, we are going to witness something almost no human ever will. Not because it is hidden, not because it is secret, but because it happens so far away, and so rarely, that most of the universe never sees it either. Somewhere in a quiet spiral arm of a distant galaxy, a star many times larger than our sun is reaching the end of its life. It is burned for millions of years. It has held itself together through unimaginable pressure. It has balanced gravity and fire in perfect harmony. But tonight, that balance ends, and what follows is one of the most dramatic transformations in all of nature. Tonight, we gently explore what the formation of a black hole actually looks like. So dim the lights, let your breathing slow, and drift with me into the final moments of a dying star. If you like my video, please subscribe my channel and hit the bell icon. Before a black hole is ever born, long before gravity begins its final takeover, there exists a star living a life that appears stable, luminous, and almost timeless. This star is massive, far larger than our sun, and from the outside it looks like a steady beacon of light, calmly shining into space. Yet, beneath that calm surface, an extraordinary balance is taking place, one that will eventually determine the star's dramatic fate. For millions of years, this star survives by maintaining a delicate equilibrium between two immense forces, gravity pulling inward and nuclear energy pushing outward. At the center of this massive star, temperatures reach tens of millions of degrees. Under these conditions, hydrogen atoms move so violently that they collide and fuse together. When hydrogen fuses into helium, energy is released in enormous quantities. That energy travels outward as radiation, pushing against the star's own weight. Gravity, meanwhile, tries constantly to compress the star, to make it smaller and denser. The star exists because neither force wins. They cancel each other out, moment by moment, year after year. This balance is so precise that even a slight change would cause the star either to collapse or to swell uncontrollably. From the outside, this long phase of stability is deceptively peaceful. The star glows steadily, casting light across vast distances of space. Planets may orbit nearby. Nebulae may drift slowly past. Nothing about its appearance suggests that it is destined to become one of the most extreme objects in the universe. And yet, the seeds of its destruction are already written into its mass. A star this large was never meant to live forever. As time passes, the star slowly consumes the hydrogen fuel in its core. When hydrogen begins to run low, the balance subtly shifts. Gravity presses harder, squeezing the core tighter. As the core contracts, it heats up even more, allowing a new kind of fusion to begin. Helium atoms now fuse into heavier elements like carbon and oxygen. This process releases energy too, restoring the balance once again. The star survives, adapts, and continues shining, seemingly unchanged to any distant observer. But this cycle repeats again and again. Each time the fuel changes, the star's core contracts slightly, heats up, and finds a new way to burn. Carbon fuses into neon, neon into oxygen, oxygen into silicon. Each stage burns hotter and faster than the last. What once took millions of years now takes thousands, then hundreds, then mere days. The star is aging rapidly, though from the outside it still appears grand and powerful. Despite its size and brightness, this massive star is living on borrowed time. The heavier elements it creates provide less energy than hydrogen did. The outward pressure weakens with each new fusion stage. Gravity grows more impatient, more dominant. Deep inside the star, the core becomes layered like an onion, with shells of different elements burning at different depths. It is an extraordinary structure, complex and fragile, maintained by physics at the very edge of possibility. Throughout this long life, the star does not struggle or resist. It simply follows the rules of nature. Gravity and fusion engage in a quiet conversation, adjusting continuously. Nothing about this phase is violent. There are no explosions yet, no collapse, no darkness. This is the longest chapter in the story of a black hole's formation, and it is one of slow, steady brilliance. From a human perspective, the stage is almost unimaginably long. Entire civilizations could rise and fall while the star calmly burns in the sky. Even galaxies slowly change their shapes, while this star remains much the same. Its light becomes a constant presence, a reminder that stability in the universe is not permanent, but it can be patient. Yet deep within the core, something irreversible is approaching. Each fusion reaction brings the star closer to a fundamental limit. The elements grow heavier, the energy yields smaller, the core grows denser, tighter, more compact. Gravity is quietly winning ground, millimeter by millimeter, atom by atom. The star does not know this, of course. It simply shines, unaware of the precise moment when balance will finally break. This quiet life is not wasted or meaningless. During this phase, the star is creating the building blocks of future worlds. Carbon, oxygen, neon, and silicon elements essential for planets and life are forged in its core. The star is a cosmic factory, patiently assembling the raw materials of the universe. Long before it becomes a black hole, it has already contributed profoundly to existence itself. Eventually, the star reaches the most critical transition of all. Iron begins to form in its core. Iron is different from every element before it. While earlier fusion reactions released energy, fusing iron consumes energy. When iron accumulates, the star can no longer generate the outward pressure needed to fight gravity. The balance that defined its entire life begins to falter. But up to that moment, the star's life is calm, radiant, and orderly. It is not a monster waiting to collapse. It is not a ticking time bomb. It is a stable, luminous object doing exactly what the laws of physics demand. The formation of a black hole does not begin with chaos. It begins with patience. Understanding this quiet phase is essential, because it reminds us that black holes are not sudden accidents of the universe. They are the final chapter of a very long story. A story that starts with light, balance, and creation. A story that unfolds slowly over millions of years before gravity finally takes control. And as we rest here tonight, breathing slowly, it's comforting to know that even the most extreme objects in the universe begin their journey in calmness. Long before the darkness, there is light. Long before collapse, there is balance. And long before a black hole forms, there is a star living a quiet, brilliant life in the deep silence of space. As a massive star approaches the end of its long life, the change does not arrive with noise or sudden violence. Instead, it begins quietly, deep within the star's core, where nuclear fusion has been working faithfully for millions of years. For most of the star's existence, fusion has been its lifeline, producing the energy needed to push outward against gravity. But now, after burning through lighter elements and progressing through heavier ones, the star reaches a critical threshold. This is the moment when nuclear fusion begins to fail, and the balance that once held the star together starts to unravel. At the center of the star, iron has begun to accumulate. Iron is the final stop on the fusion pathway for massive stars. Unlike hydrogen, helium, or even silicon, iron does not release energy when fused. Instead, it absorbs energy. This subtle shift has profound consequences. The core, once a powerful engine of outward pressure, becomes an energy sink. The star is still shining on the outside, still massive and bright, but inside, its heart is no longer supporting itself. As fusion slows and then stops in the iron core, the outward pressure that has held gravity at bay for millions of years weakens dramatically. Gravity, which has always been present and always pulling inward, now finds little resistance. The core begins to contract under its own weight. This contraction is not yet a collapse. It is more like a slow tightening, a quiet inward pull that steadily increases temperature and density. As the core contracts, something counterintuitive happens. Temperatures rise sharper, not because fusion is producing energy, but because gravity is compressing matter so tightly that particles are forced closer together. This compression generates heat, but heat alone is no longer enough. Fusion cannot restart. The star has reached a point of no return. The energy being produced by compression is fleeting and insufficient to restore balance. During these final moments of nuclear failure, the outer layers of the star remain largely unaware of what is happening deep inside. From afar, the star still appears stable, perhaps even brighter than before. In some cases, the star swells into a supergiant, growing larger and redder as its internal structure changes. To an observer, this might look like a star in its prime, when in reality, it is living its last moments. Inside the core, the collapse begins to accelerate. Electrons are forced into higher energy states, resisting compression as best they can through a principle of quantum mechanics known as electron degeneracy pressure. This pressure briefly slows the contraction, providing one final form of resistance against gravity. But in a massive star destined to form a black hole, even this quantum resistance is not enough. As the core grows denser, electrons are pushed so close to protons that they combine, forming neutrons and releasing neutrinos. This process strips away one of the last forces holding the core up. With fewer electrons to provide pressure, the collapse speeds up. The core now shrinks at an astonishing rate, falling inward at thousands of miles per second. The stage of failure is silent. There is no explosion yet, no flash of light. The drama is entirely internal, hidden beneath layers of burning shells and glowing gas. The star's outward appearance remains almost unchanged, while its core is undergoing one of the most extreme transformations in the universe. Gravity is no longer being negotiated with. It is taking over completely. As fusion fails, time itself seems to compress. What once unfolded over millions of years now happens in seconds. The core's density skyrockets. A volume of space once larger than Earth is compressed into something only tens of miles across. Matter behaves in ways that defy everyday intuition. Atoms are crushed. Electrons vanish into protons. The distinction between individual particles begins to blur. Neutrinos, nearly massless particles produced in vast quantities during this collapse, stream out of the core and pass effortlessly through the star's outer layers, carrying energy away. For a brief moment, the star becomes one of the most powerful neutrino sources in the universe. These ghostly particles escape long before any light does, silently announcing that fusion has failed and collapse has begun. The failure of nuclear fusion is not a single event, but a cascade. Each lost source of pressure allows gravity to tighten its grip further. The core no longer behaves like a normal gas or even a typical solid. It becomes an ultra-dense object governed by the deepest laws of physics. This is the threshold between a star and something far more extreme. Despite the violence implied by these processes, the collapse itself remains strangely orderly. Gravity follows geometry. Particles follow probability. The universe does not panic. It simply continues according to its rules. The star does not explode yet because it cannot. It must first finish collapsing. This moment when fusion definitively fails is the true beginning of a black hole's formation. Everything before it was preparation. Everything after it is consequence. The star has lost its ability to support itself, and no known force can restore that support. From this point forward, the outcome is inevitable. As we imagine this quiet failure tonight, it is worth noticing how different it is from our expectations of cosmic destruction. There is no sudden catastrophe, no dramatic collapse visible from afar. Instead, there is a gentle but unstoppable surrender to gravity. The star does not fight. It simply lets go. In this way, the failure of nuclear fusion is not a moment of chaos, but of transition. It marks the end of a long, luminous life and the beginning of something darker, deeper, and far more mysterious. As the core continues to collapse, the universe prepares for one of its most extraordinary creations. And as we drift closer to sleep, we can imagine that distant star, still glowing softly in the night sky, unaware that its heart has already crossed the final line. The light we see is a memory. The future, hidden within, is already sealed. As the night deepens and your thoughts begin to soften, let this realization settle in. Somewhere far away, a strange cosmic whole quietly exists, following rules we are still learning to describe. It does not rush. It does not threaten. It simply reminds us that the universe is bigger than fear and slower than worry. The stars above you are steady. The galaxy continues its graceful rotation. Time on Earth flows gently forward. Nothing about this mystery changes that. Nothing about this hole reaches into your world. And perhaps that is the most soothing truth of all. The universe is full of wonders that challenge our understanding, but very few that endanger our peace. Most mysteries are invitations to observe, to learn, to marvel rather than reasons to be afraid. As we gently arrive at the end of this journey, it's worth pausing for a moment not to solve the mystery, but to sit quietly beside it. This cosmic whole, so strange and so unlike anything we expected, does not ask for fear or urgency. It asks for patience. It asks for wonder. And most of all, it invites us to slow down and listen to the universe in a deeper way. Throughout this story, we've seen how nothing about this object behaves normally. Gravity bends unevenly. Light loses its certainty. Time stretches in unfamiliar ways. Signals whisper when they should shout, and silence appears where noise is expected. And yet, in all of this strangeness, there is no violence, no chaos, no threat, just a quiet reminder that the universe is far more subtle than our first impressions often allow. We often imagine cosmic mysteries as dramatic explosions, collisions, endings. But this mystery unfolds differently. It is calm. It is restrained. It exists without urgency, as though the universe itself is comfortable not having all the answers immediately revealed. In a way, this cosmic hole feels less like a rupture in reality, and more like a pause. A long, patient breath, held across billions of years. For scientists, this object expands the boundaries of understanding. It doesn't erase what we know, it builds gently upon it. It suggests that the laws of nature are not brittle rules, but flexible principles, capable of adapting to extremes without breaking. Gravity doesn't fail here. It deepens. Time doesn't stop. It softens. Light doesn't disappear in panic. It fades with grace. And for you, here at the end of the day, this story carries a quieter meaning. In a world that often feels rushed, loud, and demanding, the universe offers a different rhythm. It shows us that even immense power can be gentle, that even deep mystery can be calm, that not knowing everything right away is not a flaw, but a feature of existence itself. Somewhere far beyond the Milky Way, this cosmic whole continues to exist exactly as it has for ages, unchanging, unbothered, unhurried. It does not move toward us. It does not disturb our sky. It simply holds its place in the vastness, a silent reminder that the universe is large enough to contain both order and mystery in perfect balance. As you let your thoughts slow, remember this: the same universe that contains strange gravity and unfamiliar time also contains quiet nights, steady stars, and a planet where you can safely rest. Nothing about this cosmic whole reaches into your world. Nothing about it disrupts your sleep. It exists far away, doing what the universe has always done, exploring itself through endless variation. So there is no need to stay alert. No need to hold on to questions. Curiosity can rest now. Wonder can soften. The mystery will still be there tomorrow, and the universe is in no rush to resolve it. Let the idea of this calm, impossible object drift gently into the background, like distant starlight fading at the edge of vision. Let the vastness feel reassuring instead of overwhelming. You are not small in the universe, you are sheltered within it. And as the final thought settles, take comfort in this quiet truth. The cosmos is full of things that are not normal, yet almost everything about it is peaceful. The universe continues its slow, steady motion. The stars remain in place. Time flows gently forward, and you are free to let go, to relax, and to sleep.